All right, welcome back. I hope you're having an awesome time so far. Our next speaker is Douglas Hamilton. He is the Managing Director of AI at NASDAQ. Please join me in welcoming Douglas to our virtual stage.
Hi, thanks. Hi everybody. I'm here today to talk a little about NASDAQ's view of artificial intelligence, dynamic markets, the role that markets play in the broader economy and how they help us in price discovery. And finally, the role that AI plays in extending our view of highly efficient and liquid financial markets to the non-financial markets as well. So first, I'd like to start by describing NASDAQ's view of AI in the real world. Over the past few years, we've kind of honed a view of AI that's I'd say a little bit idiosyncratic to many of the Venn diagrams that you see in the world and flow charts, which describe predictive, descriptive, and prescriptive analytics, or say machine learning, optimization, deep learning, et cetera, all the way down. And instead look at AI as a series of new capabilities that allow us to tackle problems with computers that previously we wouldn't have been able to do particularly well by hand coding solutions. Broadly, these fall into one of four categories. The first is control, which we see as the ability to make real-time decisions based on inference and information. That's beyond merely prediction, but actually making strategic decisions about how systems are set up and how they should perform going forward. A great example of this in pop culture is, of course, AlphaGo, or any chess playing machine, which makes strategic decisions about where to place pieces on a board based on the current board state and occasionally exigent information about players themselves. The second capability we see AI is bringing to the world is perception. And this really, we differentiate this from prediction in that this is AI's ability to interpret the world around it. So not necessarily to say what will happen in the future, but rather to be shown an input that's not a typical computer input and make a statement about that input. Great examples of this are, of course, facial recognition, which many of you are familiar from your phones, or natural language processing, the ability for computers to read documents, gain understanding about sentiment, topics, entities, et cetera. Next, of course, is the one that most people are familiar with, which is prediction. And prediction for us is really about finding hidden relationships between data, particularly if there's some sort of temporal component, right, that separates the current observation and the thing you think will happen. Excellent examples of this are in your day-to-day life are traffic estimation. And finally, the ability to create new interactions with computing systems, which we see most common in voice assistants today, or systems that can pick up hand signals on video, et cetera. At NASDAQ, then what we do is we take these core notions of AI, control, prediction, perception, and interaction, and we turn them into tools and technologies related to financial markets. It turns out that if you're doing alternative data research and you would like to scale that capability, this is very similar to a control problem, because understanding if you can create alpha signals out of a set of alternative data is itself a strategic game that you are playing. In terms of prediction, we use AI and AI-based systems within a number of our platform businesses to provide advanced analytics on everything from what funds hold to how funds will flow. Within perception, we use this in our surveillance business to understand whether or not bad actors are playing in the market. And finally, interaction has applications in investor relations, particularly in how boards interact with their books and interact with their with investors. And the challenge for us, and where we'll spend the bulk of our time discussing today, is how we then can reimagine these same technologies and the same core capabilities that we bring to financial markets to markets everywhere. That is, markets outside of the financial domain. A good starting place before we go in and dive into what those capabilities would be, though, however, is to first understand why we need financial markets and what benefits they bring to the world. To do this, let's talk about everybody's least favorite activity, buying a new car. So the current way that you buy a new car is you say you need a new car, you might, or at least this is the way I did it when I was growing up, you might go to a dealership. Then you have to talk to a salesperson. Then another salesperson, and eventually that salesperson has to talk to their manager. And after this very lengthy process, all you have done is done a little bit of price discovery about what one dealership is willing to sell one car to you, even though that car is only a semi-unique asset. And you've wasted an enormous amount of time, or you spent an enormous amount of time and have discovered very little information about what a fair price for that car actually should be, or what the best price is that you could get. So then what you have to do is you're exhausted and you realize you have to do it again. Talk to a salesperson, and again, and talk to a salesperson. And this is really why we like having centralized financial markets, or at least why we like having financial markets. Because financial markets, or markets in general, really bring together buyers, sellers, and goods into a centralized location where they can bid on the rights to buy and sell assets, and very rapidly engage in a process we call price discovery, wherein an optimal price, or a very efficient price emerges that clears the market of that asset. And in this process, which is considerably faster than going to numerous different locations and chatting with numerous different salespeople and managers who do this for a living, you're able to find a car at a good price much quicker. So what do we mean by efficient price? And to discuss this, we need to give you three versions of the efficient market hypothesis. Because the efficient market hypothesis really is what drives the value of, efficient markets. So there's three forms of the efficient market hypothesis. There's the strong form that states that all information, both public and private, are contained within the current price of an asset. The second is the semi-strong form, which says that all public information is contained within the price of an asset, but not necessarily private information. This is the reason why people are very concerned about things like insider trading, is because it might give people an unfair advantage. And finally is the weak form, which says that really the only thing that we have in the price is the historical information about prices and returns to date, and that public information is only being slowly incorporated into the market. Whatever form of the efficient market hypothesis you subscribe to, it probably should be somewhere between the strong and the weak form. Markets provide incredibly efficient ways to get kind of a maximally efficient information extraction into price, and allow us to figure out what very complex assets, like corporations, ought to be worth, given the information we have today and given what we know about how the world operates. And it turns out that while they're sometimes lambasted, efficient markets are really nice, because they're incredibly liquid. That means it's really easy to move in and out of a position, to buy and sell assets, to buy and sell services. And as a result, also incredibly transparent. That is, you can look at a price, you understand how it got there, you understand the price formation very well, that led to the current price you see. And as a result, it's very difficult actually to make money in financial markets. Now, it turns out that most markets we engage with every day are not financial markets, and as a result are highly inefficient and have enormous gaps in supply and demand that can be meted out. For example, if we look at our car market, while thanks to some technologies and particularly websites that have popped up over the last few years, the pricing mechanism has become a little more transparent. It's still highly frictive. That is, it's difficult to move in and out of your car. It's difficult to discover the price, etc. By the same token, if you go to your local farmer's market, it might be a little more liquid. That is, it's a little more easy to go from one seller to another, or trade sellers, and move in and out of the value of your asset, because theoretically you could return something fairly easily. The price discovery mechanism at a local farmer's market is considerably more opaque than in a financial market. However, we don't just use markets to determine the assets of toys, of kind of upscale items like farmers markets, or toys like cars. We also use them for some of our most important things, some of the most important assets in society. And in fact, in some of those most important assets in society, these markets are incredibly opaque and incredibly frictive. If you think about, for example, either the rental or real estate market, this is a market that is highly illiquid and highly opaque in terms of how price discovery is done. Even worse than the real estate market and the rental market is, of course, the medical industry, the medical industry and medical services, where pricing is incredibly frictive and incredibly opaque. Many people don't even know what services cost as they go in for treatment. And these are the things that really start to, these are the sorts of markets that we begin to think about as being incredibly inefficient, and frankly are the areas where we see an enormous amount of strife, right, in day-to-day life. So how are people already using markets in new and novel ways to tackle this problem of liquidity and opacity? Well, we'll cite a few examples. One that we like to cite is StockX, which is an online marketplace for clothing reselling, primarily sneakers. And there, what we can see is something like a Jordan 1 retro high top, where a number of people are willing to buy and sell. An emergent price, a midpoint price emerges somewhere between 325 and 320. In this case, it's about 292. And we're able to price a semi-complex asset, which is a very high quality sneaker that has some collector's value at the point of time in sale. And of course, these prices fluctuate over time as demand wanes, and demand and supply wanes throughout the year. And the way these markets are structured, for those of us less familiar, is in terms of bids and asks. So there will be a set of ask prices and a number available for that ask, which is what people are effectively willing to buy for. And by the same token, a number available and a price or a bid that people are willing to sell for as well. Some other areas that we're probably familiar with very efficient markets in our lives are things like SeatGeek and other ticket resellers that allow us to bid on seats, effectively bid on seats, or at least look at what people are willing to sell seats for in very fast and very efficient ways. And as a result, we're able to fill up stadiums very reliably by allowing prices to vary with demand from individual sellers. More recently, NASDAQ partnered with Airbus to power Skytra, which sells derivative products on airline tickets. These derivative products help airline companies hedge against risk within their own flights, because most flights are sold out fairly close to the actual date of departure. The ability to hedge risk there by selling derivatives on the tickets themselves helps to smooth out the revenue of airline companies. Finally, we'll talk about the Football Index, which is a novel betting website where people are able to buy and sell shares in professional footballers, in particular the outcomes of individual games. And again, this is an example of an efficient market being applied to betting to provide very transparent and very efficient price discovery. It turns out that beyond price discovery, digitizing these markets provides additional value. So creating these sorts of digital markets around price discovery allows for custom personalization, allows us to understand the price elasticity attached to markets, allows us to generate a data stream that lets us better understand the markets, view the local liquidity, make better supply and inventory management decisions, and frankly allows for better risk management as well. And all of this is related to that notion of the efficient market hypothesis, where we view markets as a way for us to collectively unravel information about the future based on the past in a maximally efficient way. As an example, if we were to digitize create a derivatives market around for example, a good example of derivative markets in our daily lives, or that warranty markets in a lot of ways can be used to assess the likelihood of a car being a lemon. And futures markets on car is, again, a futures curve predicting the price of the depreciation of a particular make and model as well. And all of these are examples of how we can use markets to understand real assets in our day-to-day lives. So that brings us to, so now that we understand a little more about the benefits of the financial markets, or deeply liquid, highly efficient markets themselves, we'll kind of close out our thoughts here by discussing what NASDAQ sees as the commonalities between markets and the role that AI plays in solving these problems for markets outside of finance. So effectively, all markets have four core things they do. They allow buyers and sellers to search the market for available assets. They allow buyers and sellers to compare various assets. They allow them to select from among those assets, particularly buyers, and make a determination about where they'd like to place a bid or an ask. And finally, they help us uncover pricing by letting us discover a fair price. So each of these four elements have obvious solutions in kind of in modern financial markets, but need some help when it comes to non-financial markets. Let's get started. So the classic example we go to here for that first problem of searching for an asset is the problem of Apple versus apples. If I want to go buy Apple stock, it's fairly easy. I go online to my brokerage, my online brokerage. I type in AAPL, and a couple $100 later, I have myself a share of Apple stock. As soon as I want to buy apples, though, and I have to go to the grocery store, I have to select from a number of different types of apples, right? And then I have to determine something about the quality of those apples as well. And I know this is a much harder thing to do, because whenever my wife asks me to go grocery shop, I always buy the wrong type of apples, or at least reasonably the wrong apples. So as a result, we need a way to kind of resolve some of the ambiguity, the core ambiguity related to non-financial assets. Now, the typical way that we'll do this for the search component is by using a combination of established AI systems like natural language processing to find semantically similar assets. For example, if somebody types in Apple, I know that they might be looking for a Granny Smith or a Red Delicious, and that those are both types of apples that can be uncovered by modern natural language systems, as well as other sorts of personalization systems and more population-driven recommendation systems that look at what other people tended to mean or click on or select when they typed in similar phrases as well. And through this, we can help uncover or reduce the ambiguity associated with searching for reasonably novel, semi-unique assets that we see in the real world. By the same token, after we find these sorts of assets, we then need to compare them. And searching and comparing new and novel assets can be difficult. However, this is actually a problem that, again, we've seen solved with AI systems like restricted Boltzmann machines and collaborative filtering a number of times. Anytime you log into Netflix or whatever streaming service of your choice you find that they've figured out how to use large amounts of data in order to deliver to you a number of different but reasonably similar assets, in this case, movies or shows that you might consider watching, that you can quickly scan through and make a determination on which you most like to watch. So again, this leverages, in order to solve the comparison problem, we leverage again here the technology referenced earlier around things like collaborative filtering, population-based methods, as well as semantic similarity, in order to uncover these sorts of relationships and assist with finding and searching as well as comparing. Beyond that, there's also a growing interest, of course, in graph-based technology, both knowledge graphs, which are very good at representing relationships with direct and indirect within more domain-specific areas. So the rise of things like knowledge graphs, as well as graph neural networks also provides an opportunity for us to uncover more complex relationships that better allow market participants to understand the complex relationship between assets and rapidly compare and determine where they'd most like to place bids. Next, we'll talk about the third problem, which is pricing. Now, pricing in deeply liquid financial markets is actually fairly simple. Not simple, but if you see a price, you can. It's probably a decent idea to assume that for the most part that is reasonably a fair price, with some variation, of course. When we talk about less liquid assets, though, very oftentimes there's some negotiation element required to actually reach a fair or a prevailing or clearing price for a specific transaction, because of the large number of both quasi-unique elements of the asset itself, as well as the semi-unique elements of the buyer and seller who are engaging in the individual transaction. However, negotiation is a very negotiation and facilitating negotiation in a way that keeps prices transparent and fair, but also keeps people's negotiation tactics secret, can be a tricky thing. Many people view negotiation as a reasonably proprietary thing, and they don't want the ways that they negotiate to be, to share that with the world at large. This is an area where we see federated learning playing a large role. Because oftentimes, as we mentioned, buyers and sellers will want to build bots to negotiate on their behalf. Clients may not want their data to be shared, and of course, this makes it hard to train models when you don't have data to assess. So the good news here is what federated learning effectively allows us to do is, basically train models in an offline sort of way. It allows us to keep data obfuscated and share model weights rather than the data itself when thinking about how to find emergent fair prices through large-scale negotiation events. So we don't have to share the specific data that goes into these negotiations, rather with every user, rather can build models based on kind of this federated notion of learning instead. So if we think about this in terms of a traditional machine learning setup, right, all the client's data, all the negotiation data gets sent to a centralized server where the model can be trained. But within a federated system, the client keeps their data private. We run models locally and share updated models back to the server in order to engage in more, in order to give fair price discovery information to both buyers and sellers. Finally comes, and this really helps us with the notion of both pricing and then, of course, selecting. Finally, there's one last challenge here, which we haven't discussed too much, which is the notion of domain specificity, which once we do this for one domain, all of these things for one domain, we have to be able to rapidly do them for another. This is where we'll talk about our final and what we think is one of the more exciting technologies to come around in the last few years in machine learning, topic of transfer learning. As a refresher for those of you, transfer learning allows us to take data, like a financial corpus here, assess landmarks, features, and build a model that works on some market, let's say to negotiate some assets on a particular type of model. We then can find a totally new domain and re-leverage through the transfer elements that model to a new market in a much faster and much more efficient way, and create for a second type of market in a completely different domain, also a negotiation bot merely by transferring or reusing the weights from the first model. This allows us to adapt to new domains very quickly, and we've seen this be very effective in a number of different projects already. So the transfer learning process, to make it a little more tactile, works as follows. You can imagine that you have many, many, many pictures of cats. And so you build a machine learning model to assess whether or not an image is a cat or not. Well, it turns out that if you also have a bunch of images of, say, nasty things on people's lungs, you could take that problem sufficiently similar to assessing whether something's a cat or not, that rather than having to train a model from scratch, you can use the same sort of underlying technology from your first image recognition problem to your new image recognition problem with far less data. For us, what we found thus far and what we're finding increasingly in new and novel markets as well, is we're able to train where we have lots of data, like let's say on our equities market, and then transfer it to markets that don't have nearly as much data and operate under very different dynamics. And this allows us to rapidly reuse models without needing millions and millions of examples and entire research teams. In conclusion, data and AI innovations are transforming capital markets and making new and novel asset markets possible. They're doing this by taking the core components, those four core components of searching, comparing, pricing, and bidding, and allowing them to be more flexible and more adaptive in ways that we couldn't have assessed before. So with that, I will conclude my talk and take questions. Thanks.
Thank you, Douglas. That was amazing. Thank you so much for sharing with us today. We really appreciate your insights, and I know this virtual audience is going wild with virtual applause. Thank you again. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.